Namaskar and welcome to this first lecture, which is the introduction to the course on hydration, porosity and strength of cementitious materials. My name is Sudhir Misra and I'll be giving some of the lectures, and the other part will be handled by Professor K.V. Harish, who is a colleague of ours in the Department of Civil Engineering at IIT Kanpur. These are some of the references and textbooks which you could use when you listen to the lectures and want to study a little bit on your own, or try to get more information about things which are given as assignments and so on. Now, before we get started with cement paste and cementitious materials, we must understand some of the basic properties of concrete, because at the end of it, cement paste and cementitious materials are an integral part of concrete and very widely used in that form. So now, in the fresh state, we expect concrete to largely behave like a fluid, as is shown in this picture. We expect concrete to go through the reinforcement that is shown here and fill up all the gaps. That can be done with some amount of help through consolidation. Otherwise, we now have self-compacting concretes which do not require any compaction and take whatever shape the formwork has. Other than fresh concrete, we expect concrete, after it has hardened, to take the shape of the formwork. It could be cubes, it could be T's, it could be I's. We've seen so many shapes of concrete structures, and at that point we expect concrete to behave more or less like a rock. So when we are talking of cements, cementitious materials, coarse aggregate, water, mineral admixtures and any constituent of concrete, we must keep these two states of concrete in mind. We expect different properties in the fresh state and different properties in the hardened state. This is a cross section of concrete. You can see that these are coarse aggregate particles which are more or less suspended in the mortar phase. And mortar itself, if you look closely enough, we can see some finer particles here. With the naked eye, we cannot see anything finer than that. And finer than that, we have cement, and then there is of course water, except that water does not exist most of the time in hardened state, and that's the state in which this picture is taken. Water exists as part of the hydrated cement paste, which is the binder in the concrete. So the overall objective of this course is coming from the fact that over the last few decades there have been tremendous developments in the field of cement and concrete. This has been accompanied by their emergence as the backbone of development and creation of infrastructure, especially in the developing countries. This has led to the need for a revisit to basic concepts in the area, and this module is designed with the purpose of fulfilling that important professional need. The importance of cement and concrete in the present day can only be gauged from the fact that their production and consumption is one of the parameters which is used to evaluate the development in a country. Now, since it's a course, we are talking about examinations, we'll talk about quizzes. This is a homework question for you. Find out the figures for global cement production and consumption and study the trend of these figures. Try to relate that to the levels of development in different countries over time. What you will find, or what I expect you to find, is how the cement production in the world has changed, let's say in the last 30, 40, 50 years, and how it has changed as far as the global distribution is concerned. Different countries, the developed West, the developing countries now, countries like Japan, China, and how the cement consumption, the concrete consumption in these areas has changed. You will find that there is a very strong correlation between this consumption and the development that has taken place in these countries. Moving on, before we start a detailed discussion on the main subject of the course, which could be the manufacture and characterization of cementitious materials, the hydration process, and its relationship with porosity, strength, and durability, in the first module, in these few lectures, to begin the course, let us better understand the larger picture, where we will talk about a model that we use for the concrete, from the structural point of view, from the materials point of view, and also the basic properties of concrete. We must remember that only if we understand the requirements of concrete in different areas, we will be able to understand what kind of cement to use, what are the special properties that we need from the cement or the hydration products, how do we control porosity, how do we control strength, how do we control durability, and so on. So these few lectures initially are devoted to understanding concrete. Now, the constituents of concrete are coarse aggregate, fine aggregate, cement and water, and then we have chemical admixtures and mineral admixtures. The chemical admixtures and mineral admixtures have been added in brackets because these four constituents are part of the old traditional concrete which we knew. These two admixtures, chemical and mineral, are being added to concrete routinely and as part of a regular job now in the last, say, 30, 40 years, when we have better understood how concrete behaves, how cement hydrates, and what kind of concrete we need in different environments, and so on. We must remember that the coarse aggregate and the fine aggregate, they essentially work as inert materials in the concrete, and it is only the cement and water that actually hydrates and gives hydration products, and these hydration products act as binders. So in a manner of speaking, concrete can be looked upon as a suspension of fine and coarse aggregate in a binder of cement and water. Please recall that we use the word paste, which is basically cement and water. We use the word mortar, which is nothing but paste and fine aggregate, and we use concrete, which is mortar and coarse aggregate. So one way of looking at concrete is a suspension of coarse aggregate in mortar. Mortar is a suspension of fine aggregate in paste, and paste itself is a suspension of cement particles in water. We must remember that the fluid component or the liquid component of concrete is only water. Cement, fine aggregate, and coarse aggregate are all solids. We must remember that this course is not really about concrete, but about cementitious materials and their hydration and the resulting porosity, strength, and durability. But as I've pointed out, we cannot talk about it meaningfully unless we understand the bigger picture of concrete. Apart from the materials, we must remember that the basic processes in concrete construction are making the concrete, which includes material selection and proportioning, transportation of that concrete from the RMC plant to the site of placement, the placing of concrete itself, which involves the movement of concrete from the trucks to the actual site of placement, which could be the beam or the column or the slab, whatever, the wall that we want to cast, the compaction of the concrete if it is required in that place, and finally the curing. So now the properties of hardened concrete are those which evolve after the concrete has been placed and as it exists in the structure, that is the in situ properties. But those are very much affected and are very closely related to the entire set of all the other processes, the making of concrete, transportation, placing and all that. So we must have the larger picture first before we get involved with the details of the hydration of cement and cementitious materials in the presence of chemical or mineral admixtures and the resulting porosity, strength and durability issues. Now this is a very important diagram for us to understand. At the root of the entire discussion is the hydration of cement and cementitious materials with water, which gives us hydration products. Now, this phenomenon of formation of hydration products is closely related to porosity, durability and strength. And these key parameters, strength, porosity and durability, are closely related among themselves. If we want high strength, we would like to have low porosity. Similarly, if the porosity is low, the durability would be high, because it is this porosity in the hydration products that facilitates the movement of detrimental material, whether it is chloride ions or it's sulfates or it's even carbon dioxide, into the concrete. So it is impossible to talk of durability, strength and porosity independent of each other. But we must remember that at the root of all these three properties of concrete is the process of hydration. And this hydration is that of cement and water. When I say cement, I include other cementitious materials as well. And to that extent indeed, the coarse aggregate and the fine aggregate are only inert materials. Let me also throw at you another relationship with three keywords: applications, performance and economy. We have countless applications of concrete. We just have to look around and see that concrete is used in roads, in buildings, industrial structures, bridges, precast products. It could be manhole covers, it could be girders, it could be RC pipes, and all those applications have different performance parameters. We must understand our application before we can decide what the performance parameters will be, or what will be the parameters on the basis of which we will evaluate a particular concrete product. And finally, economy. Engineering without considerations of economy is pretty much a meaningless exercise. We must understand what is economical. Are we willing to pay the additional cost for the additional performance that is likely to come by for a particular application? Those questions have to be decided at the policy. Now, let us look at this picture once again, where we have coarse aggregate particles suspended in mortar, and then we cannot see the suspension of fine aggregate in paste. But what we can do is we model this in this form, and we say that, well, concrete is a suspension of these coarse aggregate particles in mortar. And in the mortar level, we say that this is basically fine aggregate particles in paste. It is obvious from this picture now that in order to control or study the properties of concrete here, the fact that these particles are largely inert, it is absolutely imperative that we understand whatever goes on in this phase, and this is the paste phase, and this paste is nothing but the hydration products of cement and water. So this course basically focuses on the hydration processes and the evolution of hydration products. Coming back to this course is designed to better understand the relationship between hydration on the one hand, porosity, strength and durability on the other. That's the slide that I showed you the previous time. And the modules that we are using to go through this exercise are a very general discussion on concrete and its properties, that is this lecture and then maybe the next two. Then we will move on to cement and cementitious materials, which would include an overview of all the materials used in concrete, including aggregates, their manufacturing processes, the quality control criteria, the specifications involved, and finally we'll embark upon a detailed discussion of Portland cement-based paste systems, which would mean we would pay emphasis to understanding hydration from the point of view of chemistry, hydration products, and their properties. Having understood the process of hydration and its chemistry and all that for ordinary Portland cement, we will move on to using mineral admixtures in the system. And then we'll graduate to the relationship between the paste and the concrete, which would include discussions like workability, strength, porosity, and durability of concrete. With this, I would like to thank you for joining in, and I look forward to seeing you in the next lectures when we talk about concrete initially, and then move on to talking about hydration, porosity, and strength of cementitious materials. Thank you.